Welcome back to Logic. I'm Tom, and in this unit, we are going to talk a little bit more in depth about inductive arguments and inductive reasoning, and go over some of the principles and practices around inductive reasoning. So, if we recall, inductive reasoning is a kind of reasoning that goes from statistics, observations, and facts and moves to generalizations about that, right? And if you recall, inductive arguments are evaluated not in terms of validity or soundness, which is only deductive, but in terms of being strong or weak in terms of the inference, right? So, um, the reason for that is that when it comes to inductive inferences, they're never 100%, right? And on the extreme side, the problem of induction is exactly this problem. Hume is famous for saying, David Hume, philosopher from 17th century or 18th century or so, said, just because the sun has risen every day that I've been alive, it doesn't follow that the sun will rise tomorrow, right? That's not to say that he doesn't believe the sun will rise tomorrow. It just means that given the facts, we can't be certain that the future will be the same as the past, right? And this also becomes a problem for other scientific generalizations, right? Just because every time I've dropped a rock, it fell to the floor doesn't mean that it will do it next time, even though we believe that there is a natural law called gravity that will determine that that's going to happen. And you can also do this about species generalizations and all kinds of things. But nonetheless, we use inductive reasoning quite often, and it's a very popular way of thinking about things and a very useful way of thinking about things. We tend to really like scientific inferences, things like the scientific method, where we make generalizations based on a series of observations and experimentation and so on and so forth. So, but when it comes to inductive reasoning, there are some things to know about facts and statistics and how we make inferences from them. If you notice, this is a little bit later in the book. I do it out of order because we do move on to our persuasive paper, where a lot of our research about some issue that you want to write about is going to be using statistics, right? And when you use statistics, you really you have a lot of room to press on statistics, right? Where do they come from? How much are they, how big is their sample size? You know, how broad is the sample size? All kinds of things about where these statistics come from and and what kind of generalizations you're making from those statistics. So that's kind of what we're going to be talking about today. Now, the first thing to mention is what they call statistical generalizations, which we've already mentioned is kind of a cornerstone of inductive inferences, right? Um, Based on, say, if you see that 100% of the crows that I've seen in my life have been black, then I can infer that crows in general are black, right? And that's a pretty heavy duty statistical generalization, but you might also have lesser ones. 60 or 95% of the time I drive the car, I don't get in an accident, something like that, and then therefore I don't think I'll get in an accident driving to the store, that kind of thing. So when it comes to statistical generalizations, you take some kind of statistic that has to do with a finite amount of uh, items, right? Whatever you're talking about, and then makes a more generalization about some kind of item in a universal sense, right? So they give the example of voters conducting a poll right, about what's going to happen in an upcoming election or something like that. I don't know if anyone has ever worked for a campaign or a polling organization, but if think about it for a second, if you want to get an accurate sense of what's going on and what voters are going to be doing, there are some things that you're going to want to avoid, and there are some things that you're going to want to do, right? So, and these are things they're talking about, like adequate sample size, right? So you want to make sure that if you are polling for, let's say, an upcoming Senate race or something like this, you want to make sure you poll enough people, right? If you poll 5 people, you're probably not going to get a really good sense of where voters are going, right? Of course, that is going to be relative based on your situation, right? Also, a non-biased sample size or a non-biased sample. So, if you are polling and you only poll 10 people who all identify as Republicans, that's not really going to be a very good poll, right? But also, you want to look at demographics, and you want to pull from people who live in different areas and have different lines of work, and different genders and race and all kinds of things, right? So you want to make sure that you have as good of a representation of your pool as possible, right? And that way, when you extrapolate from that, it will be as accurate as possible, right? Not 100%, but better, right? Um, they also talk about hasty generalization here, and that's basically just the principle of when you make a bad generalization, right? You have a very small sample size or a biased sample size, and then you make a quick judgment to about what that group is like in general, right? And so that's basically just a bad inductive inference. There are also some other, they talk about random sampling, which is something that we've talked about a little bit, but the other thing that they talk about is inference to the best explanation and explanatory virtues. I'm not going to go through all of these, but I just want to touch on them a little bit. The biggest thing with an explanation, inference to the best explanation, is usually inductive in nature, right? So they give the example of something like, you go up to your car, you notice that the window's broken and some things are missing, right? Inference to the best explanation is that someone broke in your car and stole some stuff, right? There are other possibilities, right? Someone could have um, accidentally, thrown a rock through your window and never noticed, and you could have accidentally taken some things out of your car and not remembered, right? These kinds of things. But that is a version of inference to the best, or inference to the best explanation. And we do this quite a bit, right? You look at a situation, you see some facts, you size them up, you make an inference based on that. Now, all of these principles they talk about, explanatoriness, depth, power, falsifiability, modesty, simplicity. I mean, they're all pretty elaborate concepts, and really filling them out is quite a feat. However, for our purposes, you should just have a gloss on these so that you know what they are when you start to look at some articles about an issue or whatnot. Now, when it comes to explanatoriness, depth, and so on, the biggest thing is you don't want your explanation to be another description of the phenomenon you're trying to explain, right? So, you don't want to say, oh, candidate A won the election because candidate A got the most votes, right? That's just another way of saying that they won, right? So you want it to provide some backing for the thing you're trying to explain. Falsifiability is a huge issue that actually also applies to statements in general. Remember, we talked about arguments, and that argument is a series of statements. And statements are important because they can be true or false. That means also your statements should be falsifiable, which means that you should be able to have a means to prove that they are false, right? And then the idea is that if you have a true statement, your attempts to show it's false will fail, right? So it'll prove that it's true. An unfalsifiable statement is one like there's an invisible man sitting behind me that you can't touch or see or feel, that never makes any noise, right? And then you could never prove or unprove that. It's basically falsifiability has to do with provability. um, and then also modesty, simplicity, conservativeness, these things, and they mention Occam's razor. um, uh, these all have to do with not overstepping in your explanation, because you are making a little bit of a jump in an inductive inference. You don't make too big of a jump, right? So, for example, with the car, if I notice that the window's broken, some things are missing, it's better to think that maybe someone broke into my car than to say an alien stole things from my car or a ghost broke the window, right? That is a little bit more of an overreach. It is somewhat consistent with the thing that you're trying to explain, but it is more than you need to posit in order to explain it. So that's pretty much all I wanted to cover on this. Just look over these definitions are going to be particularly important in this unit, because it's something that will definitely help you with your persuasive paper, and um, and just get a primer on inductive reasoning and statistical generalizations and how those work, and in which ways they facilitate making a stronger inference, and what things make our inferences actually weaker, right? So thank you, and see you soon.